So an electricity network is a series of components such as poles, wires, cables, power station, wind farms, solar panels on your roof that all make up an electricity network. Electricity runs in circuits, so those circuits come out from the power station. They go through substations along poles and wires and cables out to the customer, and then they would come back again to their source, which would be the power station. The main parts of the grid you may have seen are wires that are held up by poles or pylons, and underground cables you wouldn't see, but you'll see big grey boxes on poles or on the ground, which are transformers, which would change the voltage of the electricity. There are a lot of challenges to a network, such as storms, wind, rain that blow trees over, bring poles down, or too much water in the ground can get into a cable. But I suppose some of the more modern issues with the grid is about making sure that electricity is balanced. So grids are designed to take electricity from where it's made to the customer. That's how they were built years and years and years ago. So it's one-way traffic. These days though, you guys have probably got solar panels on your roofs, there are wind turbines around and other generator sources which are going into the grid. So now it's like a two-way street, and we have to try and balance that electricity in the network, because too much is not a good thing. Not enough is not a good thing, and obviously none is a bad thing completely. Western's Power is starting to use different ways to make sure everybody gets their electricity, and we can do that in a way which overcomes some of the challenges. There are some farms which have really long electricity lines just for that one farm, which is quite an inefficient way of doing it. So instead of having that long line, Western Power is now providing people like that with a standalone power system, which means it's a smaller unit which has solar panels, generators, which create electricity, and they go into a big battery. So at night or when the sun's not shining, they can use the electricity that's stored in that battery. And if that does run out, there's a diesel generator which will kick in and make the electricity for them. Similar things happens with groups of houses now sometimes, where there are a lot of solar panels on the roofs, and all of that energy goes into what they call a community battery bank, which then everybody connected to that bank can use. When the sun's down, they can draw from that battery. So when you guys come home from school and you all put on the microwaves to make yourself something to eat, and you plug in your PlayStations or your gaming tools, whatever you've got, you guys all get home from school at the same time. So all of a sudden, lots of people want lots of electricity. Giving you more power isn't always easy, but we do know. So the guys that sit in our control room, they know at certain times of day when they're going to see what we call a peak, when you guys are using a lot of electricity, and they also know when there's going to be a trough, when there's not as much need for it. So what those guys do is they try and balance the generators or the machines that make the electricity. That could be a generator or solar or wind. They will try and regulate that power coming in to try and give us a smoother track. So you think about that and how you're going to maintain your supply of electricity through your network, because rain, shine or not, you need to keep the lights on.